curious minds, welcome back to Project Excellence Prodigy, your one-stop solution for all your project management and mechanical engineering needs. I am Govind, a certified PMP and mechanical engineering professional with more than 25 years of experience in the power and energy sector. In our project management knowledge area series, we have already learned about project integration management, which is coordinating all project activities. Project scope management, which is doing the right work and only the right work. Project schedule management, completing the project on time. Project cost management, managing the project cost within the approved budget. Today, we move on to lesson 5, which is project quality management. And the theme for today's lesson is doing it right the first time. Imagine you are installing a large diesel engine in a power plant. If suppose the engine is not aligned properly during installation, everything may look fine at first. But once the engine is started, problems can begin to appear. You may notice excessive vibration, bearing damage, seal leakage, or other mechanical issues. And to fix these problems, you may have to stop the engine, dismantle the equipment, realign it, and carry out testing and commissioning all over again. This means extra time, extra cost, and delays to entire project. That is why it is always better to do the job right the first time. The same principle applies to every project. Delivering a product quickly is not enough, and completing a project within budget is also not enough. If the quality does not meet the required standards, the project may still fail. That is why project quality management is so important. Let's understand this in detail. Why quality management matters? Think about it for a moment. Imagine you complete a project on time and within budget, but the final product doesn't work as expected. Can we call that project successful? Probably not. That is because quality is just as important as time and cost. Poor quality can create several serious problems. First, it leads to rework. When a job is not done correctly the first time, it has to be done again. For example, suppose a cooling water pipe in a power plant is welded incorrectly, and during the pressure test, the weld starts leaking. Now, the faulty weld has to be cut, welded again, inspected again, and tested again. So this extra work is called rework. Rework wastes time, increases labor and material cost, and finally delays the project. Second, poor quality can lead to downtime. Suppose a pump is installed incorrectly, and after the power plant starts operating, it suddenly fails. So what will happen? The plant may have to be shut down to repair or replace this pump. This means the plant stops generating electricity, which will result in production loss and financial loss for the customer. Third, poor quality can create safety risk. For example, suppose a high pressure fuel pipe is not installed properly. It may develop a leak during operation. And fuel leaking onto hot engine surfaces can create a serious fire hazard. Similarly, poor electrical connections or incorrectly installed equipment can lead to accidents and put people's lives at risk. Finally, poor quality can damage a company's reputation. If a company delivers projects with frequent failures and repeated defects, customers lose confidence. They may not award future projects to that company. On the other hand, if you deliver high quality work, it builds trust, improves customer satisfaction, and creates more business opportunities. In engineering projects, even a small quality mistake can become a major operational problem once the equipment starts running. That is why Project quality management is not just about finding defects after the work is completed. It is about preventing defects, meeting quality requirements, and doing the job right the first time. What project quality management actually means? Project quality management is the process of ensuring that the project and its deliverables meet the required quality standards and satisfy the customer's requirements. In simple words, it is about making sure that the work is done correctly the first time, so the final product performs exactly as expected. Project quality management mainly focuses on three important areas. First, it ensures that the project meets customer requirements. Every project starts with certain customer expectations and technical specifications. For example, suppose a customer orders a 50 megawatt power plant. So he expects it to generate the full power reliably and efficiently. If the completed plant cannot achieve the required performance, then the project has failed to meet the customer's requirement, even if it was completed on time and within budget. Second, it ensures that the project deliverables are fit for purpose. A deliverable is considered fit for purpose when it performs the function it was designed for. For example, if you install a large diesel engine, the engine should start smoothly, operate within the specified vibration limits, deliver the required power output, and run without abnormal failures. If it cannot do these things, then it is not fit for its intended purpose. Third, it focuses on controlling and continuously improving project processes. Quality is not achieved only by inspecting the finished product. It is achieved by following the correct procedures throughout the project. For example, during engine installation, we should follow proper alignment procedures, correct tightening torque, approved welding methods, and inspection checklist. By controlling these processes and continuously improving them, we can reduce the defects, avoid rework, and deliver a high quality project. So remember, project quality management is not just about checking the final product. It is about ensuring that the customer's requirements are met, the deliverables are fit for their intended purpose, and the project processes are properly controlled and continuously improved. Now let's understand another very important concept in project quality management: quality versus grade. Many people think that quality and grade mean the same thing, but they are completely different. Let's understand the difference. Quality means how well a product meets its specified requirements. In other words, if a product performs exactly as it was designed to do and meets all the required specifications, then it is considered a quality product. On the other hand, grade refers to the category, class, or level of features that a product offers. A higher grade product usually has more features, better performance, or premium materials, while a lower grade product has fewer features and is generally less expensive. Grade and quality are independent of each other. Suppose a power plant requires a standard carbon steel bolt for installing a pipe support. The supplier delivers exactly the specified carbon steel bolt. It meets all the required dimensions, material specifications, and quality standards. Although it is a low grade product compared to an expensive stainless steel bolt, but it perfectly meets the project requirements. So it is considered good quality. Now consider another situation. Suppose the supplier delivers a premium stainless steel bolt, which is a higher grade product. However, this bolt has incorrect dimensions or a manufacturing defect, so it does not fit properly and fails the inspection. Although it is a high grade product, it does not meet the specified requirements. Therefore, it is considered poor quality. So remember this simple rule: quality is about meeting requirements. Grade is about the level of features or specifications. A low grade product can still be of excellent quality, if it meets all the required specifications. Likewise, a high-grade product can be of poor quality if it fails to meet those specifications. Now, let's look at the three processes of project quality management recommended by PMI. The first process is plan quality management. Second process, manage quality. And third process is control quality. Let's understand each of these one by one. Plan quality management. This is the process of identifying the quality requirements and standards for the project and deciding how the project will demonstrate compliance with those requirements. In simple words, before any actual work begins, the project team plans how quality will be achieved throughout the project. At this stage, the team answers a few important questions. What level of quality is expected? How will quality be measured? What conditions must be met before the customer accepts the deliverables? And what tools, methods, and procedures will be used to achieve that quality? Planning all these things in advance creates a strong foundation for all quality related activities during the project. So the first activity we do here is to define the quality standards. When we define the quality standards, we don't simply make them up ourselves. They come from several established sources. Some standards come directly from the customer's requirement. For example, the customer may specify the required performance, capacity, or reliability of the product. Some come from the contract signed between the customer and the contractor. The contract may include quality requirements that must be fulfilled before the project can be handed over. Quality standards also come from engineering codes, which provide technical rules for safe design, manufacturing, installation, and operation. For example, the fuel piping of a large diesel engine may need to comply with the SMA piping code so that it can safely withstand the required pressure and temperature. Another input may come from government regulations, which are legal requirements related to safety, environmental protection, and statutory compliances. Together, these sources define the quality standards that the project must achieve. The second activity is to identify the quality metrics. Quality metrics is simply a measurable value that tells us whether the required quality has been achieved. Instead of saying the alignment should be good, we define a measurable limit. For example, suppose maker specifies that the maximum allowable shaft alignment deviation is 0.05 mm. Then this 0.05 mm becomes the quality matrix. During inspection, we simply measure the actual alignment and compare it with this specified limit of 0.05 mm. Since it is measurable, so there is no confusion or guesswork. The third activity here is to define the acceptance criteria. Acceptance criteria are the specific conditions that a deliverable must satisfy before it is officially accepted by the customer. In other words, they answer the question, what must be achieved before we can say this work is complete? For example, the customer will only accept the engine installation once the alignment is within tolerance. All pressure tests are successfully completed, vibration levels are within limits, and performance testing meets the required specifications. Once we define these acceptance criteria clearly, it will help avoid disagreements later because both the customer and the project team know exactly what is required before approval is given. The fourth activity in plan quality management is to decide the quality tools, inspection methods, and procedures. Here, the project team finally decides how quality will be achieved and verified. This includes selecting the appropriate quality tools and inspection techniques that will be used throughout the project. These may include inspection checklists, test plans, measuring instruments, calibration procedure, quality audits, root cause analysis, control charts, flow charts, cause and effect diagrams, Pareto charts, sampling methods, and inspection and test plans. By selecting these tools at the planning stage, everyone knows what inspection will be carried out, when they will be performed, who will perform them, and how quality will be verified. Second process of project quality management is manage quality. In plan quality management, we decided what quality is required and how it will be achieved. Now, in manage quality, we actually put that plan into action. Manage quality is the process of translating the quality management plan into day-to-day project activities. Its main objective is to ensure that the project team follows the planned quality processes and continuously improves the way work is performed. Manage quality focuses on preventing defects from happening in the first place. That's why we say manage quality is a proactive process. It is about building quality into the work rather than trying to inspect quality at the end. Let's understand its three main focus areas. The first focus of manage quality is improving project processes. Remember, good quality doesn't happen by accident. It comes from following good processes. Suppose your team is installing large diesel engines at multiple power plants. After completing the first installation, the team realizes that the engine alignment process takes much longer than expected because different technicians follow slightly different method. So instead of continuing with the same inefficient process, the project manager standardizes the alignment procedure, creates a detailed work instruction, and provides additional training to the team. As a result, the next installations become faster, more consistent, and produce fewer alignment errors. This is process improvement. Instead of correcting the same problem repeatedly, we improve the process so that the problem doesn't occur again. The second focus is preventing defects. This is one of the biggest difference between manage quality and control quality. Just think about it. Which is better, finding a defect after the installation or preventing that defect from occurring in the first place? Obviously, prevention is always better than cure. For example, suppose you are installing a cylinder head on a large diesel engine. So before fixing the cylinder head, you will make sure that matting surfaces are clean and you are using the correct gasket. You will verify the tightening sequence and you will verify the torque given to the nuts. Because these checks are completed before the installation. So the chances of water leaks, compression leaks or gasket failure are greatly reduced. So instead of fixing problems later, the team prevents them from happening. That is exactly what managed quality is all about. The third focus is ensuring that everyone follows the approved procedures. Even the best procedures are useless if people ignore them. For example, the maker may specify the foundation bolt must be tightened in a particular sequence using a calibrated torque range. Suppose if a technician decides to tighten the bolt in a random order or use the ordinary spanner instead of calibrated torque range, so the quality of the installation may be affected. Therefore, during managed quality, supervisors verify that approved procedures, work instructions, safety practices, inspection methods, and quality standards are actually being followed throughout the project. Another important concept in managed quality is continuous improvement. Continuous improvement means we never assume our current process is perfect. Instead, we continuously look for small ways to improve it. These improvements may seem minor individually, but over time, they lead to significant improvements in quality, productivity, and efficiency. In simple words, small improvements today lead to big quality improvements tomorrow. Let's look at some techniques which are commonly used for continuous improvement. The first technique is the PDCA cycle, also known as the Deming cycle. It consists of 4 simple steps. First is plan. Identify a problem and plan an improvement. For example, the team notices that the engine alignment is taking too long, so they develop a new alignment procedure. Next step is do. They will implement this new procedure on a trial basis at one of the engine installation. Third step is check. They will evaluate the results. Did the new method reduce installation time? Did it improve alignment accuracy? Did it reduce rework? The final step is act. If the improvement is successful, they will make it the new standard procedure and implement it across future projects. If it doesn't work, revise the plan and repeat the cycle. This continuous cycle helps organizations improve quality step by step. Root cause analysis. Sometimes defects occur repeatedly. Instead of fixing the same problem again and again, we should identify why the problem occurred. This is called root cause analysis. For example, suppose a diesel engine encounters excessive vibration after installation. The easy solution here would be to keep realigning the engine every time. But root cause analysis goes deeper. The team investigates and discovers that the actual problem is not the alignment process. Instead, the engine foundation is settling because the grout curing procedure was not followed correctly. Once the real cause is identified and corrected, the vibration problem disappears permanently. So that's the purpose of root cause analysis. Eliminate the cause, not just the symptom. Another important technique is capturing lessons learned. Every project teaches us something. Some things go well, some things don't. At the end of the project, or even during major milestones, the team documents what worked well, what problems occurred, and how those problems were solved. The next project uses the same approach, making future work faster and more efficient. Over time, these lessons become valuable knowledge for the entire organization. Now let's move to the third and final process of project quality management, which is control quality. What we discussed so far, plan quality management tells us what quality is required, and manage quality helps us build quality into the project by following the right processes. Now comes control quality. This is the process of checking the completed work to verify that it meets the required quality standards. In simple words, once the work is completed, we inspect, measure, test, and verify the deliverables before they are accepted by customer. The first activity involved in this process is inspection. Inspection means carefully examining the completed work to check whether it complies with the required specifications. For example, after installing a large diesel engine, the inspection team visually checks the engine foundation, piping connections, electrical wiring, supports, and accessories. They verify that everything has been installed correctly according to the approved drawings and procedures. If anything is missing or incorrectly installed, it is identified during inspection activity. Next activity is testing. Inspection alone cannot always confirm whether the equipment will perform properly. That's why we carry out various tests. For example, during commissioning, the engine is started and operated at different loads to verify that it produces the required power, maintains normal temperature and pressures, and operates without abnormal vibration. So testing confirms that the equipment performs as intended under actual operating conditions. Another important activity in this process is measurement. Many quality requirements are expressed as measurable values. So the project team measures important parameters and compares them with the specified limits. For example, they measure crankshaft alignment, vibration levels, bearing temperatures, lube oil pressure, cooling water temperature, generator voltage, If all measured values fall within the specified limit, the deliverable meets the required quality standards. The final activity is verification. Verification means we confirm that all inspection tests and measurements have been successfully completed, and the deliverable satisfies the acceptance criteria which were defined during the planning stage. Only after successful verification, the customer formally accepts the completed work. So in simple words, verification answers one final question. Does the deliverable fully meet the required quality requirements? If the answer is yes, it is accepted. If not, the corrective actions is required before acceptance. Quality control tools. To perform control quality effectively, several quality control tools and documents are used. Checklists. It ensures that every inspection point has been verified and nothing has been overlooked. For example, before handing over a diesel engine, the project manager will follow an installation checklist to confirm that all required activities have been completed. Measurements. Measurements provide the objective evidence that the deliverable meets the specified limits. These values are compared directly with the manufacturer's specifications. Test reports. After every inspection or performance test, the results are documented in a test report. For example, pressure test reports, load test reports, vibration reports, performance reports. These all will provide evidence that the equipment has passed the required tests. Calibration records. The accuracy of inspection result will depend on how accurate are your measuring instruments. That's why the project team maintains calibration records for all measuring equipments like torque wrench, pressure gauge, vibration meters, thermometer, and alignment instruments. The calibration record will prove that the measuring tool which we are using is reliable. Non-conformance reports, NCRs. Sometimes after inspection, we identify that some work that does not meet the required specification. In such cases, a non-conformance report or NCR is raised. NCR records the defect, explains what requirement was not met, identifies the corrective actions required, and tracks the issue until it is fully resolved. This ensures that no quality issue is ignored before the project is handed over. Now let's understand another very important concept in project quality management, which is called the cost of quality or simply COQ. When people hear the term cost of quality, they often think it means the cost of producing a high quality product. But that's not correct. The cost of quality is the total cost associated with achieving quality and dealing with poor quality. In other words, it includes the money we spend to prevent defects, to check quality, and to fix problems if defects occur. Cost of quality is divided into two main categories. The first is conformance cost and the second is non-conformance cost. Conformance costs are the cost we incur to ensure that the work is done correctly the first time. It is like the investment in quality. We spend this money to prevent mistakes and to verify that everything meets the required standards. Conformance costs are further divided into two parts: prevention cost and appraisal cost. Prevention costs are the cost of preventing defects before they happen. The idea behind this is very simple. It is always cheaper to prevent a problem than to fix it later. For example, before installing a large diesel engine, the company may spend money on training technicians, preparing detailed work instructions, calibrating all the required measuring tools, qualifying welding procedures, and conducting quality planning meetings. All these activities cost money, but they significantly reduce the chances of installation errors, rework, and equipment failure. So these are called prevention cost. The second type is appraisal cost. These are the cost of checking whether the work has been completed correctly. In other words, we inspect, measure, and test the work before handing it over to the customer. For example, after installing a diesel engine, the project team will perform all the required checks like crankshaft alignment, pressure test, vibration measurement, load testing, and final inspection. These inspections require manpower, measuring instrument, testing equipment, and documentation. All these expenses are appraisal cost. Now let's look at the second category. These are the non-conformance cost. These costs occur because quality requirements were not met. In simple words, these are the cost of poor quality. Instead of preventing problems, we are now paying to correct them. Non-conformance costs are divided into internal failure cost and external failure cost. Internal failure costs are the cost of defects that are found before the product reaches to the customer. For example, during commissioning, engineers found that the crankshaft deflection is outside the allowable limit. Since the problem is detected before handover, the team must stop the work, realign the crankshaft, repeat the measurement, and perform another trial run. This entire activities will require additional manpower, extra material, project delays, and rework. This defect was found inside the project before customer acceptance. So these are called internal failure costs. On the other hand, external failure costs are much more serious. These occur when the defect is discovered after the customer has accepted the project. For example, imagine the power plant starts commercial operation. After a few weeks, a cooling water starts leaking because it was not welded correctly during installation. Now the customer reports this problem. So to handle this issue, company must send service engineers to the site, replace damaged part, stop the equipment for repair, and may even have to compensate the customer for production losses. And in addition to the repair cost, the company's reputation may also suffer. These are called external failure costs. External failure costs are usually the most expensive because they affect not only money but also customer satisfaction and future business. So remember this simple rule. Conformance costs are the cost of doing things right. These include prevention cost and appraisal cost. And non-conformance costs are the cost of doing things wrong. These include internal failure cost and external failure cost. A good project manager always tries to increase the investment in prevention and appraisal because spending a little more on quality at the beginning can save a huge amount of money later. So that brings us to the end of today's lesson on project quality management. I hope you found the lesson useful. If you did, please like, share and subscribe to Project Excellence Prodigy. In our next lesson, we will explore project resource management. Till then, namaste, goodbye, sampai jumpa.